Alright, well, in this video I'm going to show you how to determine if a set of data is normal or not. So we talk a lot in this class about normality and determining normal and standard distributions. But one of the things we haven't talked too much about is how do we look at a set of data and make sure that it really is normal. And so this is a lesson really on using technology to help us with this question. How do we determine if a set of data is normal? Okay, and so we're going to actually be using the DVD, the CD for this. So if you have the CD and you open it up, it should have these files in it, and you're going to go into Appendix B datasets. We're going to use Microsoft Excel, and the file that we're looking for here is F health right here. Okay, so you double click on that. Now it opens up this raw data here, and this is a whole lot of information, and we're actually only going to use just a little bit of this. So the first thing you want to do is save this under a different name, and I am going to save this right on my desktop as, let's see here, I'm going to call this women's height. Okay. So the question that we are going to work with here is the distribution of women's height a normal distribution or not? Okay. So let me just delete all this other stuff here that I don't really need. So I'm going to right click here and just get rid of that column and get rid of the age column and really get rid of everything except the height. Okay, and then I'm just going to right click in here and just put in a few extra rows just so I have a little space at the top here. And so the first thing that we can do to determine whether data is really normal as a good guideline is to create a histogram. So what I'm going to do here is just make a different section out here, and I'm going to call this section the histogram section. Okay. And when I make a histogram, I need some bins, and then I need frequency. In other words, I'm creating a frequency table so that I can later on create a actual histogram. Okay. And so to do this, I'm going to figure out the minimum and the maximum value here. So min, we'll type equals using the minimum function and highlighting everything in this data set. And there, so you can see the smallest value that's available here is 57. Let's find the max value using the max function. Let me change the zoom on here so it's a little bit easier to see. So max equals max, and the same set of data out here. Okay, so these are my minimum values and my maximum values, and you can see that the range then between these two is 11. Okay, so it's ranging between 57 and 68. So what I'm gonna do then is try to have about 5 different bins. Okay, so the first bin that I'm going to have is every number that is less than 59.2. And the reason I'm getting this number, so my range is 11, and I want 5 bins. So I just do 11 over 5. So that means every increment is going to go 2.2 at a time. So my first bin is really everything between 57 and 59.2. Then my next bin is going to be between 59.2 and 2.2 more than that. So it's between 59.2 and 61.4. And I'm just going to do this all the way down. So it's between 61.4 equals the previous cell plus 2.2. And the the last one is between 65.8 and 68. Okay, so the first one is everything less than 59.2. The second bin is everything between 59.2 and less than 61.4, and so on for all of these. And the last one is everything between 65.8 and 68. Okay, now the frequency, so I'm basically counting all of these numbers and seeing how many of them fall into each of these range. And Excel has a really nice feature here that'll help us to do this fairly quickly. So the first thing I need to do is highlight the entire section here, the entire column here, so that it matches up with the bins. Okay, and then just while the entire thing is highlighted, I'm going to type equals frequency, and notice here, look at what it's asking me. It's asking for a data array and a bins array. So the data array is all of the numbers in the raw data. Okay, and now it's asking me for the bins array, which is all of these bins right here. So I'm going to highlight this and close the parentheses. And before you hit enter, it's very important because we've highlighted an entire array here, an entire list of cells, not just one individual cell. So when you hit enter, you have to hit Command Shift Enter. I'll say that one more time. Command Shift Enter if you're using a Mac. If you're using a PC, it's Control Shift Enter. Okay, and let me just highlight these sections so we can see a little bit better. And then to make the actual the histogram, I'm going to highlight all of my frequencies, go into charts, and I'm looking for a column chart, and just the first one here, the cluster column will do. Okay. And there you have it. So along the x-axis here, these should list the bins. Okay, and so I need to change this. Along the y-axis is the frequency. So let me delete some of this other stuff with the series there. I don't really need a legend since I pretty much just only have one set of data here. Okay. Now you click on your chart, go into chart, source data, and notice here this says series 1, and I want to have x-axis labels. So I click on this little icon, highlight the actual bins, and then click on that icon one more time and hit OK. And now you can see my histogram is updated with these specific numbers. Okay. I also want to label my y-axis here, so open up the toolbox, and under chart options here where it says titles, we're looking for vertical, and we'll change this to say frequency. And let's make our chart look just a little bit bigger here so that everything can fit on it. Shrink this section just a little bit, and there you have it, a histogram of all of the women's heights. And I can look at this histogram and see that it's going to be probably normal. I can't be sure 100%. In the next video, I'll show you exactly how we can be sure. But for now, we can look at the histogram as a way to just help us get a general idea. And the thing about using histograms is that if something follows a normal shape in a histogram, we can't be certain. But if something does not follow the shape of histogram, we can say right then and there that it's not going to be a normal distribution. So it is a necessary condition to determine the normality of a distribution, but it is not by itself sufficient. For that, we have to take one more step, and that's what I'm going to do in the next video by showing you how to determine, how to plot a quantile plot. Okay, so but right now, this is the histogram.